Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating world of static single assignment, SSA, a fundamental concept in compiler design. It's all about how to efficiently represent programs, making them easier to optimize. Ready to get technical?
Absolutely. I've always been intrigued by SSA, but the sheer number of papers on the topic can be overwhelming. What's the core idea behind SSA, and what are some of the key papers you've highlighted?
Exactly. The core idea is simple. Each variable is assigned only once. Sounds straightforward, but it has profound implications for optimization. Think of it like giving each value its own unique identifier, eliminating ambiguity. Now, about those papers. We have a rich history here, starting way back in the 1980s. Early work, like Zadek's papers on code motion and global value numbers, laid the groundwork. But the real breakthrough came with Citron's 1991 paper, which introduced a method for constructing SSA using dominance frontiers. It's a classic, but it involves some pretty heavy-duty graph algorithms.
So, Citron's approach is the gold standard? Not quite, right? I mean, it's influential, but not necessarily the most practical for all scenarios.
You're right to challenge that. While Citron's paper is seminal, it's not always the most efficient. Later papers offered simpler alternatives. Brandeis and Mossenbach's 1994 paper, for instance, showed you can generate SSA during parsing, bypassing the need for complex algorithms if you're dealing with structured languages without go-to statements. Much simpler, and often faster.
That's a huge simplification. So simpler approaches exist for specific cases. What about more recent developments, or roaches? Are there any modern approaches that build upon these earlier ideas?
Absolutely. There's a whole range of approaches. Aycock and Horsepool's 2000 paper, for example, starts with Appel's crude algorithm and iteratively refines it, removing unnecessary phi nodes. Then there's Bebenita's 2009 work, which uses union-fine data structures for a very elegant solution. And even more recently, Lemaire's 2023 paper frames SSA construction as an abstract interpretation problem, a very advanced and powerful perspective.
Wow, this is a constantly evolving field. It's amazing how many different angles there are to tackle this problem. And what about the Sea of Nodes IR by Click and Polexny? That sounds particularly interesting.
Oh, the Sea of Nodes is a fascinating alternative. It essentially unschedules instructions, making code motion much easier. It's a different paradigm, but it shows the flexibility of the SSA concept. And of course, there's a whole world beyond the core algorithms. Extensions to SSA, analyses built on top of it, and the crucial task of converting out of SSA for register allocation. It's a deep rabbit hole.
It certainly is. This has been a fantastic overview. It's clear that SSA is far more than just a simple program representation. It's a rich area of research with many different approaches and ongoing developments. Thanks for shedding light on this complex topic.
My pleasure. And remember, listeners, this is just a glimpse into the world of SSA. There's a wealth of resources out there, including the comprehensive SSA book mentioned in the article. Keep exploring, keep learning, and happy compiling. Thanks for tuning in to Tech Bytes and News. Have a great day.
Bye-bye.